March 7, 1944, dawned with the thunderous roar of naval bombardment echoing across the coral atolls of the Central Pacific. Commander Robert Yarborough of the United States Navy Construction Battalion, better known as the Seabees, stood on the deck of a transport vessel, watching the island of Majuro emerge from the morning haze like a jewel scattered across the endless blue. The smoking remains of Japanese fortifications dotted the landscape, but Yarborough's mind was already racing beyond the immediate tactical victory. He had received orders that seemed to defy the very laws of engineering and logistics. Construct a fully operational airstrip capable of handling heavy bombers within 20 days of landing. The Japanese had held these Marshall Islands for over 2 decades, transforming them into fortified stepping stones across the Pacific. Their engineers, renowned for meticulous planning and execution, had spent months constructing their own military installations. The idea that American forces could not only capture these strategic positions but also build superior infrastructure in a fraction of the time seemed preposterous to Imperial Command. Intelligence reports filtering through Tokyo dismissed the possibility as American propaganda, designed to boost morale rather than reflect reality, as documented in wartime correspondence later published in the Naval Historical Center's Seabees History. The Japanese military leadership fundamentally misunderstood the revolutionary approach that Admiral Chester Nimitz and his Pacific Fleet had developed. Unlike traditional military engineering, which relied heavily on civilian contractors and lengthy supply chains, the Seabees represented something entirely new: combat-ready construction battalions equipped with both rifles and bulldozers, capable of building under fire while simultaneously defending their worksites. Yarborough's 53rd Naval Construction Battalion had trained for 18 months in the harsh conditions of Camp Peary, Virginia, where they had perfected techniques that merged rapid construction with military precision. Each Seabee carried multiple specializations: welding, heavy equipment operation, demolition, and small arms proficiency. They had studied aerial photographs of Pacific atolls until they could identify coral compositions and drainage patterns from memory. Most importantly, they had developed prefabricated construction methods that could transform raw terrain into operational airfields with unprecedented speed. The Japanese defenders who had survived the initial assault watched in bewilderment as American landing craft disgorged not just Marines and soldiers, but massive earth-moving equipment and construction materials. Bulldozers, graders, and portable concrete mixers rolled off LSTs with mechanical precision. Within hours of securing the beachhead, Seabees were clearing vegetation and conducting soil surveys while combat operations continued less than a mile away. This simultaneous approach to warfare and construction violated every conventional military doctrine the Japanese had studied. What the Imperial forces could not comprehend was the industrial might that supported these seemingly impossible operations. American factories had retooled their entire production capacity for war, churning out specialized equipment designed specifically for rapid Pacific construction. Prefabricated steel matting, portable concrete plants, and modular fuel storage systems represented innovations born from necessity and American industrial ingenuity. The Seabees weren't just building airstrips. They were deploying an entirely new form of warfare that combined military conquest with immediate infrastructure development, creating an unstoppable momentum that would carry American forces across the Pacific toward the Japanese homeland itself. The morning sun of March 8th revealed the true scale of the Seabees' revolutionary approach to military construction. Lieutenant Colonel James Patterson, the battalion's engineering officer, stood amid the organized chaos of the construction site, clipboard in hand, orchestrating what appeared to be an impossible ballet of machinery and manpower. Every movement had been choreographed months in advance, every piece of equipment positioned according to carefully calculated efficiency studies conducted at naval training facilities across the continental United States. The Japanese observation posts, hidden in the remaining jungle canopy, transmitted increasingly frantic reports to their regional command. The Americans weren't following any recognizable construction methodology. Instead of the methodical, sequential approach that Japanese engineers employed, clearing, then surveying, then grading, then building, the Seabees operated multiple phases simultaneously across different sectors of the airfield site. While bulldozers cleared coral and vegetation on the western approach, Other teams were already laying steel matting on the eastern runway foundation that had been prepared just hours earlier. This parallel construction technique had been perfected through intensive study of American industrial production methods. Henry Ford's assembly line principles had been adapted for military engineering, creating what naval architects called horizontal integration of construction processes. Each CB unit functioned as a specialized component in a larger machine, with precise timing and coordination replacing the traditional hierarchical approach to military projects. The Japanese, whose own engineering philosophy emphasized perfectionist craftsmanship over speed, found this American methodology both fascinating and terrifying. According to declassified reports from the Office of Naval Operations, later archived in the National Archives Pacific War Collection, Japanese intelligence analysts struggled to comprehend the logistical framework supporting these rapid construction operations. American supply vessels arrived with cargo pre-sorted and pre-positioned according to construction schedules that had been calculated weeks in advance. Steel runway matting arrived in sections numbered and color-coded for specific placement positions. Concrete mixers came pre-loaded with aggregate materials measured for exact sections of runway foundation. The Seabees' secret weapon wasn't just their machinery or their training. It was their revolutionary approach to problem-solving. Traditional military engineering relied on detailed advance planning and rigid adherence to established procedures. The American construction battalions, however, had been trained in adaptive engineering, constantly modifying their methods based on real-time conditions. When coral proved harder than expected, they immediately shifted to different equipment combinations. When tropical rains threatened concrete curing times, they deployed portable heated enclosures that maintained optimal drying conditions. Japanese engineers monitoring the construction from concealed positions reported that American work crews operated in 12-hour shifts around the clock, with seamless transitions between day and night operations. Powerful electric generators illuminated construction sites with artificial daylight, allowing precision work to continue regardless of natural light conditions. This 24-hour construction cycle was unprecedented in military engineering, made possible only by the massive logistical support system that American industrial capacity could provide. Perhaps most remarkably, the Seabees demonstrated an entirely new relationship between combat and construction. Traditional military doctrine separated fighting forces from engineering units, keeping construction personnel safely behind established front lines. The American construction battalions, however, worked with weapons within easy reach, ready to transition from bulldozer operation to defensive combat at a moment's notice. This combat construction integration allowed them to begin building immediately upon securing territory, without waiting for traditional security perimeters to be fully established. The Japanese had never encountered anything like this fusion of warfare and engineering, and their tactical responses proved completely inadequate to counter this revolutionary approach. March 10th brought with it a symphony of industrial power that reverberated across the captured atoll like thunder from a clear sky. Chief Petty Officer Michael O'Brien guided his massive Caterpillar D8 bulldozer across terrain that had been impenetrable jungle just 48 hours earlier. The machine's tracks crushing coral and volcanic rock with mechanical indifference. Behind him, a convoy of specialized construction equipment stretched across the newly cleared landscape. Road graders, compaction rollers, portable concrete plants, and the revolutionary Marston mat-laying machines that had transformed American military engineering capabilities. The Japanese prisoners held in temporary compounds watched this mechanical parade with expressions ranging from disbelief to professional admiration. Many were engineers themselves, veterans of extensive construction projects across the Japanese Empire's Pacific territories. They had spent months building defensive installations using traditional methods, hand tools, small equipment, and careful, methodical approaches that emphasized permanence over speed. The American machinery represented industrial capabilities that exceeded anything in the Japanese arsenal, equipment designed specifically for rapid deployment and immediate productivity. Each piece of American construction equipment embodied years of industrial innovation driven by wartime necessity. The Caterpillar bulldozers had been modified with reinforced blades and upgraded engines capable of continuous operation in tropical conditions. Road graders incorporated hydraulic systems that allowed precise control over surface preparation, essential for creating the perfectly level foundations required for heavy bomber operations. Most revolutionary were the portable concrete plants, self-contained factories that could produce construction-grade concrete from local materials within hours of being positioned and activated. As documented in technical reports compiled by the Army Corps of Engineers and later published in Engineering Victory, How Technology Won World War II, the American construction revolution extended far beyond individual machines to encompass entirely new approaches to equipment integration. The Seabees deployed equipment clusters, coordinated groups of machines that worked in sequence to complete specific construction phases. A typical cluster included bulldozers for clearing and rough grading, followed immediately by fine graders for surface preparation, then compaction equipment, and finally specialized laying machines for runway surfaces. The Marston mat system represented perhaps the most significant innovation in rapid airfield construction. These interlocking steel planks, manufactured in American factories and shipped across the Pacific in standardized loads, could create operational runway surfaces over almost any terrain. Each mat section weighed exactly 100 pounds, allowing two-man teams to position and connect them with mechanical precision. The interlocking design distributed aircraft weight across the entire surface, enabling heavy bombers to operate from runways that would have required months of concrete work using traditional construction methods. Japanese engineers studying the American construction methods identified several technological advantages that their own military-industrial complex could not match. American equipment featured standardized components and universal spare parts, allowing rapid field repairs and maintenance. Japanese construction equipment, while often superior in individual craftsmanship, relied on specialized parts that required factory production and extensive supply chains. The American approach prioritized functionality and replaceability over perfectionist engineering, creating systems that could operate effectively under combat conditions. The psychological impact of this mechanical superiority extended beyond its immediate tactical advantages. Japanese forces throughout the Pacific began reporting that American construction capabilities represented a fundamental shift in the nature of warfare itself. Traditional military strategy assumed that captured territory required extensive time and resources to become operationally useful. The Seabees' ability to transform raw terrain into strategic assets within weeks meant that every American victory immediately became a platform for subsequent operations, creating an unstoppable momentum that Japanese defensive planning could not counter. The machines weren't just building airstrips, they were constructing the infrastructure of inevitable American victory. The pre-dawn darkness of March 13th was shattered by the distinctive whine of Japanese Betty bombers approaching from the northwest, their engines straining against the weight of high-explosive ordnance intended to destroy the nearly completed American airstrip. Seaman First Class Anthony Kowalski dropped his welding torch and grabbed his M1 Garand rifle in a single fluid motion, the transition from construction worker to combat soldier as natural as breathing. Around him, dozens of other Seabees made identical transformations, proving that Admiral William Bull Halsey's vision of warrior builders had become tactical reality. The Japanese air raid represented a desperate attempt to disrupt construction operations that had already exceeded their most pessimistic projections. Imperial intelligence had predicted that American forces would require at least 60 days to establish operational airfield capability, providing adequate time for reinforcement and counterattack. The sight of nearly completed runway sections barely 2 weeks after the initial landing had prompted emergency orders from Tokyo. Destroy the airfield at any cost, before American heavy bombers could begin operating from this strategic position. Bombs fell in carefully planned patterns across the construction site, targeting fuel storage areas, equipment parks, and runway sections with precision that demonstrated extensive aerial reconnaissance. Japanese pilots had studied detailed photographs of the American construction progress, identifying critical vulnerabilities in the infrastructure that could halt operations for weeks if successfully destroyed. What they had not anticipated was the Seabees' revolutionary approach to defensive construction, which incorporated bomb-resistant design principles into every aspect of their rapid building techniques. The Marston Mat runway sections, designed by American engineers who had studied German bombing tactics in Europe, proved remarkably resilient to aerial attack. Individual mat sections could be damaged or destroyed without compromising the structural integrity of surrounding runway. As more importantly, the modular design allowed rapid repairs using pre-positioned replacement materials. Within hours of the bombing raid, Seabee repair crews were replacing damaged sections and restoring full operational capability to runway surfaces that Japanese pilots believed they had successfully neutralized. According to operational reports filed with Pacific Fleet Headquarters and subsequently archived in the Naval Historical Center's Construction Under Fire collection, the Seabees' defensive preparations had been as carefully planned as their construction operations. Equipment parks were dispersed across multiple locations to prevent single attacks from disabling entire constructio and capabilities. Fuel storage utilized underground tanks and camouflage distribution systems that could continue operating even after direct hits on surface facilities. Most importantly, critical construction materials were stockpiled in quantities that could absorb significant losses without delaying project completion. The psychological impact on Japanese aircrews proved as significant as the physical damage to American construction operations. Pilots returning from bombing raids reported that American construction activity resumed within hours, often while smoke was still rising from damaged areas. The sight of Seabees simultaneously fighting fires and laying steel matting contradicted very assumption about the relationship between combat operations and construction projects. Japanese tactical doctrine assumed that engineering units would cease operations during active combat, requiring extensive security before resuming construction activities. The morning after the air raid, Japanese reconnaissance flights revealed the true extent of American construction resilience. Not only had the bombing failed to significantly delay airfield completion, but construction had actually accelerated in some areas where damaged terrain had been regraded to improve specifications. The Seabees had turned destruction into opportunity, using bomb craters as drainage systems and cleared areas as equipment staging zones. What should have been a devastating tactical setback had become merely another engineering challenge to be solved through American industrial ingenuity and determined execution. The Japanese high command began to realize that they were facing an enemy whose capabilities extended far beyond traditional military metrics, an adversary that could literally build victory from the rubble of temporary defeat. March 18th marked the beginning of the final construction phase, as the rising sun illuminated 6,000 feet of nearly completed runway stretching across what had been virgin coral atoll less than 2 weeks earlier. Commander Yarborough stood at the planned control tower location, surveying a transformation that defied every established principle of military engineering timelines. The massive runway stretched before him like a concrete and steel testament to American industrial determination, its surface gleaming with fresh Marston mat sections that would soon bear the weight of B-24 Liberators and B-25 Mitchells. The construction site buzzed with the controlled frenzy of final preparations. Seabees worked with the precision of Swiss clockmakers and the intensity of men who knew that history was watching their every move. Fuel storage systems were being connected to underground distribution networks that would supply dozens of aircraft simultaneously. Communications equipment, ship PED and modular sections from naval installations in Hawaii was being assembled into a comprehensive air traffic control system capable of coordinating complex bomber formations. Japanese observers, both prisoners and hidden reconnaissance teams, watched these final preparations with growing recognition that they were witnessing something unprecedented in military history. Traditional airfield construction projects required months of careful planning, extensive site preparation, and methodical installation of support systems. The Americans had compressed this entire process into a timeline that Japanese engineers had previously considered physically impossible, accomplishing through industrial might and innovative techniques what conventional wisdom deemed unrealistic. The technical achievements extended far beyond mere construction speed to encompass comprehensive operational capabilities that rivaled permanent military installations. Underground fuel storage systems included sophisticated pumping mechanisms that could simultaneously refuel multiple aircraft while maintaining strict fire safety protocols. The runway lighting system, powered by portable generators positioned in bomb-resistant installations, provided night operational capabilities that exceeded those available at many established military bases throughout the Pacific Theater. As documented in post-war technical analyses compiled by the Smithsonian Institution's National Air and Space Museum, the Seabees rapid airfield construction incorporated advanced engineering solutions that had been developed specifically for Pacific warfare conditions. Drainage systems designed for tropical rainfall patterns prevented runway flooding during monsoon seasons. Coral aggregate foundations provided excellent load-bearing characteristics for heavy bomber operations, while utilizing locally available materials that minimize supply chain requirements. The final construction phase demonstrated the full integration of American industrial capabilities with military operational requirements. Precision instruments for aircraft navigation were installed by specialists who had been trained at naval air stations across the continental United States. Radio communication equipment provided direct contact with fleet headquarters and bomber command centers thousands of miles away. Weather monitoring instruments, essential for safe heavy bomber operations, were calibrated to Pacific atmospheric conditions that differed significantly from continental weather patterns. The approaching completion deadline created an atmosphere of intense focus among construction crews, who understood that their work would immediately become a crucial element in ongoing military operations. Every rivet, every electrical connection, and every surface preparation would be tested within hours by aircraft carrying combat loads against Japanese targets throughout the Central Pacific. There could be no margin for error, no second chances for corrections, and no tolerance for anything less than perfection in construction standards. As the sun set on March 18th, Commander Yarbrough realized that his men had achieved something that would fundamentally alter Japanese perceptions of American military capabilities. The completed airfield represented more than rapid construction. It embodied a new form of warfare. The MIPA combined conquest and immediate infrastructure development into an unstoppable strategic advance. Within 24 hours, American bombers would be launching from this runway toward targets that had been considered safely beyond American reach just 3 weeks earlier. The pre-dawn hours of March 20th brought with them the rumbling thunder of approaching aircraft engines that signaled the moment of ultimate validation for 3 weeks of unprecedented construction effort. Major William Wild Bill Henderson guided his B-24 Liberator through the tropical darkness toward what charts designated as Airfield 77, though the pilots had already begun calling it Miracle Strip, in recognition of the engineering achievement that had created this operational base from raw coral atoll in less than 20 days. Henderson's bomber represented the leading edge of the 7th Air Force's first operational mission from the newly completed airfield, carrying a full combat load of high-explosive ordnance destined for Japanese installations on Vache and Maloelap atolls. The success or failure of this mission would determine whether the Seabees' rapid construction techniques could the intensive bomber operations that American Pacific strategy required. Every aspect of the airfield's design and construction would be tested under the most demanding conditions possible. Night operations with heavily loaded aircraft operating at maximum gross weight. The runway lights gleamed through the tropical humidity like a jeweled necklace stretched across the dark ocean, their precise spacing and intensity carefully calculated to provide optimal visibility for heavy bomber operations. As Henderson lined up his approach, he could see Seabee ground crews positioned along the runway edges, their portable communication equipment providing real-time updates on wind conditions, visibility, and runway status. These same men who had been laying steel matting and pouring concrete just hours earlier were now serving as the air traffic control system for complex combat operations. The Liberator's main landing gear touched down on the Marston mat surface with barely a tremor, the interlocking steel planks distributing the aircraft's 40,000-pound weight with mechanical precision across the coral foundation. Henderson felt the gentle rumble of mat sections transferring load stress exactly as American engineers had calculated, providing a landing surface that rivaled permanent concrete runways at established military bases. The moment represented more than successful aircraft operations. It validated an entirely new approach to military engineering that would revolutionize Pacific warfare. Behind Henderson's lead bomber, 11 additional B-24s approached the runway in carefully spaced intervals, their engines thundering across water that had been undisturbed by military aircraft just 3 weeks earlier. Each successful landing demonstrated the remarkable precision of Seabee construction techniques and the effectiveness of rapid deployment engineering methods that Japanese military planners had dismissed as impossible propaganda. The sight of a full bomber squadron operating from what had been enemy territory less than a month earlier represented a strategic transformation that would reshape the entire Pacific campaign. Ground operations proceeded with the smooth efficiency of a well-rehearsed ballet, as Seabee ground crews guided bombers to hardstand areas that had been precisely positioned for optimal fuel and ammunition loading procedures. Portable fuel trucks, supplied through underground distribution systems that the construction battalions had installed during the final construction phase, began the complex process of preparing each aircraft for combat missions against Japanese strongholds throughout the Marshall Islands chain. The integration of construction and operational capabilities had created a self-contained military base that could support sustained bomber operations immediately upon completion. According to operational reports filed with 13th Air Force Headquarters and later archived in the Air Force Historical Research Agency's Pacific Airfield Development Collection, the first night's operations exceeded all projected performance parameters. Runway surface conditions remained excellent despite heavy aircraft traffic and tropical weather conditions that had begun during the afternoon. Navigation and communication systems functioned flawlessly, providing bomber crews with precise guidance for complex night formation flying over vast ocean distances. The psychological impact on Japanese forces monitoring American radio communications proved as significant as the tactical advantages gained through rapid airfield construction. Intelligence intercepts indicated that Japanese commanders throughout the Marshall Islands were reporting the impossibility of defending against an enemy that could establish operatio null airfields faster than defensive preparations could be completed. The Seabees hadn't just built an airstrip. They had constructed the infrastructure for inevitable American victory across the entire Central Pacific theater. The emergency conference room deep within the concrete bunkers of Imperial General Headquarters in Tokyo buzzed with urgent conversation as senior staff officers struggled to comprehend intelligence reports that challenged every assumption about American military capabilities. Admiral Chuichi Nagumo, veteran of Pearl Harbor and Midway, stared at reconnaissance photographs that showed fully operational American bomber formations taking off from airfields that had not existed 3 weeks earlier. The impossible had become routine for an enemy whose industrial and engineering capabilities seemed to operate outside the normal constraints of military logistics. Lieutenant General Harukichi Hyakutake, recently returned from disastrous campaigns in the Solomon Islands, presented detailed analyses of American construction techniques that his engineers had observed before being forced to evacuate their positions. The Americans, he explained to incredulous senior commanders, had somehow merged combat operations with construction projects, creating warrior engineers who could build airfields while simultaneously defending them against counterattack. This fusion of fighting and construction violated every principle of military engineering that Japanese doctrine had established. The technical reports compiled by Japanese intelligence analysts revealed construction capabilities that exceeded the Imperial Army's most optimistic projections for their own engineering capabilities. American construction battalions deployed equipment that could move more earth in a single day than Japanese engineering units could displace in a week using conventional methods. Portable concrete plants produced construction-grade materials at rates that required permanent factory installations in Japanese experience. Most disturbing, American construction quality remained consistently high despite unprecedented construction speeds. Intelligence intercepts of American radio communications provided additional evidence of construction capabilities that Japanese military planners found difficult to accept. American engineering units reported completion schedules that Japanese calculations indicated should require 4 times longer under optimal conditions. Weather delays that should have halted construction for days were overcome through techniques and equipment that Imperial engineers had never encountered. The Americans seemed to have developed solutions for every obstacle that traditional military construction considered insurmountable. As documented in post-war interviews archived in the National Diet Library's Pacific War Leadership Studies, Japanese military leaders initially dismissed reports of rapid American airfield construction as propaganda designed to demoralize defending forces. The concept that enemy forces could establish operational bomber bases within weeks of initial assault seemed so far beyond reasonable military capabilities that high command assumed intelligence reports were being deliberately falsified by demoralized field commanders seeking to excuse tactical failures. The emergence of sustained American bomber operations from recently captured positions forced a fundamental reassessment of Japanese defensive strategy throughout the Pacific theater. Strategy. Onal defensive planning assumed that captured territories would require months of development before becoming operationally significant, providing adequate time for reinforcement or counterattack against extended American supply lines. The Seabees' rapid construction capabilities eliminated these traditional defensive advantages, creating immediate threats from every successful American landing operation. Japanese engineering officers who had been captured during recent operations provided detailed testimonies about American construction methods that their interrogators found difficult to believe. Descriptions of around-the-clock construction operations, equipment capabilities that exceeded Japanese industrial production, and construction techniques that prioritized speed over traditional craftsmanship seemed to describe an enemy operating with entirely different technological and industrial foundations than Japanese military experience could comprehend. The psychological impact on Japanese military morale proved as devastating as the tactical advantages gained through rapid airfield construction. Field commanders throughout the Pacific began reporting that traditional defensive preparations were inadequate against an enemy that could establish operational bases faster than defensive positions could be fortified. The Americans had fundamentally altered the mathematics of Pacific warfare, creating strategic momentum that Japanese defensive capabilities could not counter through conventional military responses. The Seabees represented more than exceptional engineering. They embodied American industrial might transformed into unstoppable military advancement. The morning sun of March 21st illuminated a scene that would forever alter the trajectory of Pacific warfare, as the completed airfield bustled with the coordinated chaos of full-scale bomber operations that had seemed impossible just 3 weeks earlier. Commander Yarborough stood beside the operational control tower, watching B-24 Liberators taxi along runways that bore the permanent imprint of American industrial determination and engineering innovation. The 20-day construction miracle had become operational reality, validating construction techniques that would be replicated across hundreds of Pacific atolls and islands in the months ahead. The strategic implications of the Seabees' achievement extended far beyond the immediate tactical advantages of a single airfield to encompass a fundamental transformation in the nature of military campaigns themselves. Traditional warfare had assumed lengthy pauses between conquest and operational utilization of captured territory, providing defeated enemies with opportunities for reinforcement, counterattack, and defensive preparation. The ability to establish operational military bases within weeks of initial assault eliminated these traditional strategic breathing spaces, creating relentless momentum that Japanese defensive planning could not accommodate. American military leadership quickly recognized the revolutionary potential of rapid construction techniques that the Seabees had perfected under combat conditions. Admiral Chester Nimitz immediately ordered the expansion of construction battalion training programs and the development of specialized equipment designed specifically for Pacific Island operations. The SUCS at the Marshall Islands Airfield became the template for what military historians would later term conquest construction, the seamless integration of military victory with immediate infrastructure development that would characterize American operations from the Marianas to Okinawa. The industrial implications proved equally significant as American factories retooled production lines to support the massive logistical requirements of rapid Pacific construction. Marston mat production increased dramatically to supply dozens of simultaneous airfield construction projects. Specialized construction equipment was designed with Pacific operations specifically in mind, incorporating lessons learned from the 20-day construction miracle that had validated entirely new approaches to military engineering under combat conditions. Japanese military response to American rapid construction capabilities forced fundamental changes in imperial defensive strategy throughout the remaining Pacific territories. Traditional fortification methods, which emphasized permanent defensive installations constructed over months or years, proved inadequate against an enemy that could establish operational bases faster than defensive preparations could be completed. Japanese commanders began implementing desperate measures, including the pre-destruction of potential airfield sites, in futile attempts to slow American construction capabilities that seemed to overcome every obstacle through industrial might and innovative engineering. According to comprehensive studies compiled by the Naval War College and later published in Victory Through Construction, the Seabee Revolution in Pacific Warfare, the 20-day airfield construction at the Marshall Islands became the foundation for operational techniques that would enable American forces to sustain offensive operations across vast Pacific distances without the lengthy supply line vulnerabilities that had historically limited military campaigns in ocean theaters. The ability to establish forward bases immediately upon conquest created strategic flexibility that Japanese defensive planning could not counter. The human dimension of the Seabees' achievement resonated throughout American military culture, creating legendary status for construction battalions that had proven themselves equal parts warrior and builder. The men who had accomplished the impossible under combat conditions became symbols of American industrial determination and innovative problem-solving capabilities that had transformed military engineering from methodical peacetime construction into rapid deployment warfare support. Their achievement demonstrated that American victory would be built as much as fought. The legacy of the 20-day airfield construction extended beyond World War II to influence American military doctrine for decades afterward. The concept of warrior engineers capable of fighting and building simultaneously became integral to American expeditionary warfare planning, creating specialized capabilities that would prove essential in subsequent conflicts around the world. The Seabees had not merely built an airfield, they had constructed a new form of warfare that would carry American forces to victory against any enemy willing to underestimate the power of American industrial determination combined with innovative military engineering. The impossible had become inevitable through the marriage of American ingenuity and unstoppable determination to achieve victory regardless of conventional limitations.